Okay, so good evening, everyone, and a very warm welcome to this Hazards Forum event, where we're going to learn about robots we can trust and unlocking the UK's potential in smart machines. My name's Louise Vassy. I'm Chair of the Technical Advisory Committee and also Head of Membership and Operations for the Hazards Forum. Just before we get into the exciting bit, the subject that I've just mentioned to you, just need to bring to your attention a few emergency procedures. So we're not expecting a fire alarm or a drill. I'm not expecting a drill. So if it does go off, it's a two-tone klaxon, and you'll need to evacuate the building by evacuate the lecture theatre by the two doors that are marked, and make your way out onto the main floor, and you'll be guided out by One Great George Street staff, taken to an assembly point. I'm sure you found the bathroom facilities already up on the first floor, and I hope you got the chance to enjoy a cup of tea or coffee and some biscuits earlier this evening. So I think without further ado, I'm going to hand over to your event chair for the evening. I'm very pleased to introduce to you Mark McBride, who chairs our interest group on emerging technology risks and is also Principal Inspector with the Office for Nuclear Regulation. So, Mark, over to you.
Very good. Thank you very much, Louise. And may I extend my welcome to all of you to this event on robotics and autonomous systems. Welcome to those who have joined us in the room here in the Institution of Civil Engineers in London, and welcome as well to those joining us online. Thank you for taking the time to participate in this event. As Louise said, my name is Mark McBride. I'll be your host for this evening. I'm a member of the Hazards Forum, and I chair, as Louise said, our interest group around emerging and future tech. So the title of the event this evening is Robots We Can Trust, Unlocking the UK's Potential in Smart Machines. And I'm delighted to say that in bringing this event to you, we've teamed up again with the National Committee on RAS Regulation, Standards and Ethics. So a special thanks to our colleagues in the National Committee for their contribution to this event. And you'll be hearing more about their work during the course of the evening. Earlier this year, the government published its Smart Machines Strategy for 2035. And their report identified that the UK is ranked third in the world in terms of the quality of its research in robotics and autonomous systems. Yet, in terms of deployment of those technologies, it is behind many of the other major economies in this world, less than half in terms of deployment of robotics in UK industry. So why is this? And that's one of the questions that we'll be looking to answer tonight. And I'm very glad to say that we have the support of a very distinguished panel of speakers to help us with that, and I'm sure many other questions too. So to introduce our panel tonight in order, we have Vaibhav Puri, and Vaibhav is Director of Sector Strategy and Transformation at the Rail Safety and Standards Board. We have Dr. Qitao Zhang, and Qitao is Senior Lecturer in Robotics and Director of the Robotic Systems Research Group at Queen Mary University of London. Thirdly, we have Dr. Isidro Durazzo Cardenas, and Isidro is a Senior Lecturer in Life Cycle Engineering at Cranfield University. And last but not least, we have Dr. Steve Davis, who is a Senior Research Fellow in Robotics and Operational Director of the Birmingham Institute for Robotics at the University of Birmingham. So In terms of the agenda for this evening, I'll shortly introduce the speakers one by one. They'll speak for around 15 minutes, and then we have around 30 minutes at the end for audience Q&A. So please have a think about the questions that you want to put to the panel. Your contributions will be really welcome, and we look forward to a fruitful and insightful discussion. For those of you online, you can post your questions in the chat as we go along, and we will be monitoring those questions and I'll be putting them to the panel, as many as I can, during that Q&A session at the end. So without further ado, let me introduce our first speaker, Vaibhav Puri. Vaibhav, the floor is yours.
Thank you very much, Mark, for that introduction, and thank you very much for having me today to speak to you all, and thank you for coming and all the people online. My name is Vaibhav Puri. I'm the Director of Sector Strategy at the Rail Safety and Standards Board. It's an independent body that covers sort of safety, standards, sustainability, and research in the rail sector. I lead a team in there called Futures Lab, which explores how emerging and new tech can impact the sector and how we can be prepared. I also have a second hat on today. I'm also the co-chair of the National RAS Regulation Standards and Ethics Committee, and we'll speak a little bit about their work and where it's headed and how that can help unlock robotics and its potential for the sector. For those of you looking for really, really cool videos and lots of talk about robotics, you'll have to wait 15 minutes because I'll hopefully set the scene, and then you can the people who actually are experts in the field can take the floor. Three main areas of focus, and I'll try and do that in 15 minutes. A little bit of a discussion around the state of play around RAS and key challenges, unsurprisingly. Some Mark has already alluded to. The RAS Committee's focus and journey to put the context together, and then what is the way forward for 25-26 to address some of the challenges that perhaps I will speak about. And esteemed colleagues will come in and perhaps tell you a little bit more about the wonderful technology and how it's evolving. The first point for me really is often in these discussions around robotics and autonomous systems, I find there's confusion around what problems sit where. And it's important to sort of think about RAS in three ways, certainly from my perspective. RAS as a piece of technology and often around autonomy and enabling innovations that make it happen, even possibly AI in it. The big discussion becomes about acceptance criteria and safety principles. It's fundamentally around the nature of the technology that we're talking about and the nature of autonomy that it'll have. Then there's RAS as a product, and I think that's quite important, sort of tangible systems designed for specific applications. And this is where regulatory frameworks and cross-acceptance becomes a key issue. And then beyond that, the thinking about RAS as transformative change. I think this is essential. This is about how it will reshape industry, how it will change operations. And that's when public and co-worker sentiment, ethics, and those aspects become very, very clear. Now, obviously, these three things are linked, but it's important to think about those three things in separate boxes as much as we can conceptually and really try and see how challenges can really be addressed. If we think about robotics and RAS as a technology and as a product, I was speaking to somebody about what is the solution to all of this, and typically in my fashion, I was really getting into details around regulation, and they said, "Look, this is quite a simple problem. It just has to be very, very cheap." I think that's what you're really talking about. Once this becomes cheap, there won't be any barriers. So it's useful to really think about what the archetype pathway is to becoming cheap. So we start with early adoption and development happening in labs, and I'm sure my colleagues will tell you about all the wonderful stuff they're doing in labs. You get into early adoption, high cost, niche, government investing in things, people seeing rather strategic investment, which the government is almost seeing, and allowing this first adoption to occur. Scaling and competition, some degree of standardization, interchangeable components, supply chain forms. RAS becomes a market in itself, a mature market. We start to see some economies of scale, standards start to develop. There already are some, but even more sector-specific ones and cross-sector ones. And last but not least, you get demand driving production, and suddenly, the technology is cheap enough to be in our homes. I mean, if you think about the autonomous Hoover that you have in your house, all of a sudden it's in your house, and one of the reasons it's affordable and it's available to consumers. The question is, where are we at now? We can debate this in the Q&A. Maybe we think we're kind of in the early stages, specific niche applications, and the real idea is to move into that space, to get into scaling. So scaling is the big problem. So there's the problem of early adoption, which I'm sure my colleagues will talk about, and people actually implementing RAS. But from a regulatory and a governance perspective, the big question is, how do you scale this up? If you think about rail, for example, the big challenge is not just a technical one, it's just very expensive. And if we're thinking about scale, we have to create a market, which means the scale has to be across sector. So people have to be developing products that can be deployed in multiple sectors and common areas, and that increases the market, allows for operational interchangeability to occur. And that's one of the big things that the committee is focused on. And last but not least, there's a real need to think about economies of scale and mass adoption, but we're further away from that. Us as a committee, I'm sure you've all heard, there's a Regulatory Innovations Office set up by the government. It's really focusing on how you can have more progressive and interesting and open regulatory approaches. And it's recognized that autonomous systems will require some degree of change to the existing safety and compliance frameworks. And one of the ways of really thinking about it is to compare ourselves internationally, what is happening elsewhere. If you think about South Korea, for example, there's a huge progressive movement in RAS. They're right at the top. They have a particular area, I think it's Daegu, I may be mispronouncing it. It's a regulation-free zone where you can deploy robots. They're thinking about a robot tax. So a tax so that ethics and other aspects are actually really, when you introduce robots, you're really thinking about human beings and the price that has on possible jobs and changes associated with sectors. So very progressive thinking. If you think about Norway is thinking about robotic regions. We are starting to do that with RAS hubs that the government has announced. So there's a lot to borrow and learn from other sectors. And really, there's an opportunity here for the sector to improve. We're an interesting case. I think, Mark, you talked about the fact that we are third. I've heard we are first in research. We're third in private sector investment, believe it or not, in early adoption. We are, I think, top 10 in autonomous vehicles, ninth, so we can move up, but certainly in the top 10. We're seen as incredibly mature when it comes to robotics and regulatory frameworks. But we're poor in deployment. I think robots deployed per 10,000 manufacturing workers, I think we have something like 112. And just to put some perspective on this, Korea is at about 1,000. Okay, that is the difference. Deployment, we are far behind, which does not make sense based on what I just said, how far ahead we are. So really, there is something going on here that can really unlock the potential that the UK has. And this is why the committee exists. I'm one of the co-chairs. It's co-chaired by colleagues from NNL, from University of Birmingham with Samia Mezinho OBE. Also HSC is involved, and we are very, very active. It's a very diverse membership. It has government bodies, regulators, standards bodies, infrastructure managers, covering 16 sectors of economic activity. And the big idea here is to connect regulators with organizations that are developing robotic solutions and see how we can find a way forward. I think that is the real unlocking factor here. A brief history of the committee, formed in 22-23, worked with the ministers. There was a task group set up and a regulatory scan proposed somewhere in 24. We've had some very good discussion with DCIT and Rio and people who run those departments to see how we can support the sector and make some genuine recommendations back to ministers and people in power so they can unlock things. And we're very, very keen to work with people possibly online today or here. So please do discuss stuff with us. Very quickly, the last bit of work we did, we talked to around 60 organizations, a lot of work, a couple of workshops to really explore what the challenges were, to really talk to the community to understand what is stopping robotics from being deployed. And two key lessons came through. In some cases, there were some fundamental problems with the existing legislation. And legislation change is very difficult, so you have to lobby and convince government to really do that and highlight the benefits of it. And the other bit was the perception of what the regulatory mechanisms and the burdens that come with it, the concept of regulatory burdens. So in some cases, even if the regulation wasn't the factor, the perception that the regulation creates a burden, even if it's not true, was a big factor. And in some cases, it's just a lack of understanding. So I was giving an example. If you have a robot, a machinery directive is needed and you're trying to deploy it in rail, the moment it has wheels on it, it becomes a train. You have to comply with rail regulations. Then you have to integrate it with a management system of an organization. And if you take it to a construction site on the railway, then construction CDM regs apply. So that's 4 different regulatory mechanisms that somebody has to navigate to actually deploy something on the field. And if you do not understand them, or there is no support structure to help you navigate that, you will find that as a regulator, there's nothing wrong with the regulations, but you will find that a burden. And that's one of the things that the committee is trying to unlock. The big focus is some kind of repeatable approach, really planning, scoping, designing. I'll speak a little bit about it, sourcing participants and information, regulatory deep dive, and last but not least, some recommendations back to government. And the idea is for this to be a repeatable process so that the committee can consistently every year work on 1, 2, 3 projects that are out there and really get the lessons out there. And the key thing I pointed out before was scaling. So the scaling could be a common application which can be moved across. It could be across regions. It could be across sectors, and really explore how we can work with that first of a kind and really pull the lessons out so that the second person doesn't have to start from scratch. I think that's the key thing we have to unlock. Things to think about that we will think about certainly is, where's the technology at? What is the technology readiness level? Are we talking about places which are ready for deployment? So there are companies out there who have a robot but just can't find a place to deploy, a customer to buy it, and there's an element of proving it. Or there's an area of opportunity where some regulatory change can really unlock something big for robotics. Cross-sector applicability, as I talked about, is quite important. Deployment environments which are common, construction sites, depots. So if you have a maintenance depot in rail, how is that different to a maintenance depot for aviation? If somebody is deploying drones there, which are autonomous, can it be done in the railway as well? What are the challenges associated with that? But also particular environments which are public facing, where you have to go across multiple regimes, where in the agri sector, if you're deploying robotics, it has to cross a road, suddenly highways aspects apply, you go to another site. So there could be all sorts of challenges associated with deploying robotics. I talked about RAS exposure to the public. What are you talking about? Controlled environments, exposure to public. Milton Keynes example I was talking about, robot running around doing logistics. If you prove that, to what extent can a robot be deployed in a station environment? Discuss what are the challenges. So there's clearly room for extension, but somebody has to do some thinking around that. Level of regulatory change, what's the problem? Is the problem regulation, or is this just the perception of a regulatory burden? Is it lack of data, risk assessments? You don't have criteria. And how can we unlock that? Again, the committee is very keen to work with people to unlock that where possible, because we have access to regulators. I can see some of them in the audience. Hopefully they won't be too unkind to me afterwards. The other aspect here is really scale of the benefits, really. What are we talking about? Does it unlock a pilot scheme, a deployment? What does this mean for the sector? Does it position the sector really to transform and put UK on the map in relation to a particular sector or not? So I think those are the kind of considerations. And the idea is to then highlight some cases, work with them. Like I said, we're working on a couple already. Just give you a rail example. One of the things we're doing, it sounds very simple, is to explore and examine the standards that exist, operational standards, for example, and really see to what extent are they ready for a robotics, for a RAS system to be introduced. Are there any challenges? Do the people working in that environment have to do things differently? What are they? And I think unless we proactively think about this and start to provide opportunities and test beds, I think we'll be forever behind. So I think there's a real chance for all the sectors to really grasp this opportunity and proactively think about it. Like I said, we're in phase 2 and 3, speaking to people. We'll do this again. If you have ideas, you want to work with us, please reach out. We're happy to listen. Hope is that we will get some regulatory pathways going, try and understand how a particular project has been successfully deployed in one area. What can we learn from that? How can we take it across? And maybe during Q&A, I can give you some more examples. And the expected outcome, this is the last slide, is that we identify specific barriers there's bits of knowledge and archetypes that and knowledge products that we pick up from our experience in working with partners, and that can be made publicly available. I think that's essential, publicly and freely available for projects to really use and publicize. The committee is really there to do its job, to really put RAS on a map, but also really reach out to people who are really trying to break the market to say, is there a way we can link you back to regulators to really understand? Can we provide sandboxes? Are there opportunities here to really help awareness and support you and hold your hand while you try and attempt to implement the pilot? So I'm not a robotics expert, but as you can see, I'm really excited by this, and I really wanted to succeed. And I will pause there because, to be quite honest, I want to see all the cool videos that the rest of the panel will share with you. So thank you very much for listening.
Thank you so much for giving us a great introduction to our topic this evening, and explain the work of the National Committee on RAS Regulation Standards and Ethics, which I think you get a sense of the work that's being done to really be proactive, bridge that gap between developers and those who understand the regulatory landscape, to really accelerate the deployment of robots that are safe and trustworthy and bring societal benefit. So let me, without further ado, introduce our second speaker of the evening, and that is Dr. Qitao Zhang. Qitao, the floor is yours.
Okay, and wait for the slides to. Okay, good evening, everyone. Thank you for joining this session. It's my honor to be here and present our work we have done at Queen Mary, the Center for Advanced Robotics. So a bit exciting news. I just promoted to reader, and I hadn't got time to update Mark. Sorry about that. And so yeah, Mark, please. If I play too many exciting videos, you can remind me and stop my presentation. Yeah. So today my talk is about how we combine robotics and AI to deliver like safe remote operations in hazardous environments. So first of all, I would like to briefly introduce ARQ, which is Center for Advanced Robotics at the Queen Mary. We are one of the major national research center for robotics, and we have over 50 members, including staff and postdocs and PhD students. So we have a number of key research areas. We look into mechatronics, control vision, and sensing devices. And we also have looking into how we actually design robots, which is, as I've mentioned several times, it's a kind of like smart machine. And we also looking into biology, how we actually learn from biological system. We learn from nature to have more like sophisticated robotic systems. And so here are the key research themes. We have 8 areas, including soft robots. So that is one of the key topic I'm going to talk about here, and also their applications in the extreme environments. Of course, we look into all the related areas, so making the all the comprehensive research center. So come back to the topic that I want to cover related to deploy smart machines in hazardous environments. So here we have luckily was involved in the National Center for Nuclear Robotics between 2016 and 2020. And so we were partnered with Birmingham University and other universities and to work on robots, how actually we can deploy that to the nuclear decommissioning facilities. And so we have mainly, at Queen Mary, we mainly worked on 4 research topics, including how we actually deliver the sensor to the site, which is dangerous for our human workers, so then we can to be able to see the environment that we can't see before. We have these such robotic systems, and then we have also sensors, and we can deploy manipulators where we can actually grasp or pick up those dangerous objects remotely. And then we have the teleoperation, which is actually enable our human workers to stay in the safe environment, but actually can precisely control the robots which has been deployed inside those dangerous environment. And so, as mentioned, the robotic robots are the smart machines. So if we want to design a machine that is smart and robust, that can be used or can be deployed, or bring them outside of the lab and place in the real environment, as I mentioned, not just in the lab. So first thing we think about the design philosophy. So from my research, we focus on actually learn a lot from nature system. If we look into our human bodies, we have rigid parts as skeleton, we have soft part like tissue and muscles, and then we have our brain to control. And how do we control our muscles? Actually, we learn gradually from a child, kids, and toddler. We grow up. So then we learned a lot of skills. That is what today the AI is doing. Actually, we talking just a little bit about AI, how that actually can be deployed to smart robot, which is a embodiment of the AI. And so here we talk a bit about how we design mechanically intelligent bodies that can actually do the work with very limited control requirements. So here we look into the traditional artwork, which actually is the art which called origami folding. So we learn from origami folding from this artwork. So we actually can understand about how we can use basic geometry to understand their folding from like a piece of paper to a compact 3D structure. And then we develop the design approach, and then we can look into the new manufacture approach, like how we use a 3D printing and print a piece of flat sheet, and then we can fold it into a 3D structure. And so we used this heat pressing manufacturing process, and then we use all the plastic fabric materials, and then we can use very basic mold, aluminum mold, and then we put 3D printed skeleton, and then we can actually melt the TPU materials, film materials onto the skeleton, and then we use other no melting material, so they can actually creating the chambers, so which allow us to inflate and deflate the structure. So this is the whole manufacturing process, which is cheap and actually making the body very reliable, and no electronics inside here. And then we can actually making the artificial muscle here. You can see the video. We actually can vacuum the muscle, and it can lift quite heavy payload compared to their body. So this is kind of like a new artificial pneumatically actuated artificial muscles. And so you may ask, okay, what kind of like applications? So we can actually integrate this muscle with drones, and then you can see when the drone fly in the path, and then you can actually have kind of like collision with the environment. So that kind of like a softness allow the drone to pass, and without actually because of a collision, and you can get the drone damaged. And so then we're talking about sensor delivery, and we are also developing snake robots, which is the shape actually is looking like a snake, and then we can actually go through very narrow openings, and then is of course is remotely operated, and then with camera, this is just a minimum electronics put inside the at the tip of the snake robot, and actually we can do the inspection, see the cracks or any area that is not available for other larger robots. This part of the work was founded by the Innova UK, and that was led by Professor Kaspar Schofan, who was unfortunately he's not available today. and with our colleagues. And so again, what I want to emphasize our work, what I'm presenting here is try to minimize the application of electronics, which is one of the most weakness part when we deploy the this type of robots in nuclear environment, because that part is the most easily damaged, can be easily damaged. So here again we look into the soft muscles, and then we learned a bit about from our human body. So our hand can do very precise grasping or gripping, is because our skeleton bones in the finger. So that allows the precise motion. So when we integrate the hard part and also soft parts, so making the hybrid system. And so we learned about the gait. We developed this two-legged robots, and then you can see here on this robot, again, no electronics, and then we remotely controlled by pressure in the full muscles, air pressure in the full muscles. Actually, you can see we can allow the robot to locomote. And interestingly, with this same robot, we can achieve different gaits. So from the top one is the straight locomotion, and the bottom one is the pure rotation. And then we can combine the turning, like, like a crab, but it just have two legs. And of course, we can change between the gait, and then it allows the robots to navigate through narrow channels. Like here, we try to provide a very narrow opening to allow the robot actually to go through, because it can change the gait. So again, so this is just the mechanical intelligence and no electronics. Okay, and we put the electronics at the behind, not in the dangerous environment. And so after that, actually, we also developed this variable stiffness. Like we want the device to have a different stiffness when it can change the stiffness. Where we want them to be soft, they can change to a lower stiffness, or we can want them to be able to carry more payload. So this is experiment test of this new kind of like a rotary joint with, again, powered by the pressured air. And let's move to the next slide. Yeah. And so you may ask, okay, what the joint can be used? So use the joint, we developed this quadruped robot. And so basically it's a four-legged robot, and then we use 8 of the variable stiffness joint and develop this quad robot. And if you learn nowadays, you may see a lot of very advanced legged robots developed by Boston Dynamics or by Unitree, but they all have electrical motors. For us, because we aim is to develop minimalized robots with minimized electronics on their body. And so this one is again has no electronics, and we put the marker on the reflecting marker on the robot legs, and then we put on the treadmill to allow us to learn the gait, and then to see how we can actually improve the control systems. And these are the data that we learned from, captured from the tracking system. And then we can now the robot actually can move by itself, but still need some support, of course, from our learning process. We learned that pneumatics has their disadvantages. They have pressure drops, and they have, if you have a very long tubes, and then you need very high pressure. So something always have advantages and they have disadvantages. So that is what we are trying to improve. And so we also, as what I mentioned, so we want some end effectors to be able to grasp objects in the dangerous environment. So then we develop this, again, soft gripper. So inside this one, we have just the 2 motors. Again, we try to minimize the use case of the electrical motors and the circuits, and all the fingers, they are made out of the soft material, use the TPU pulse actuator to change the stiffness. If you look at our finger, the last 2 digits, they are coupled. So we can't bend these 2 joints separately. But with the new pulse actuator, we can actually bend our that finger separately. So that means we have more configurations, and the actor, we can change their symptoms, allow them to operate for different functions. And lastly, you may think, okay, so are these robots purely can be used in dangerous environment? But it's not. But here is actually our current work, funded by Innovate UK, as Mark mentioned early. So indeed, soft fingers, we can put that to grasp soft fruits, red fruits, and so this is our work working with Saffron Grange and Extend Robotics. Saffron Grange is a vineyard near Cambridge, and then we put the soft fingertip there, and actually it can allow us to also sensor embedded there, and we can allow the fingertip to test how much force applied on the grapes or on the bunch. So then we can actually use the VR-based teleoperation to operate the robot remotely and to help the farmer to pick the grapes. But this what I'm presenting here is because this robot can be also used in like nuclear facilities, and the operator can sit far away from the exactly like dangerous environment or the operate site, but can accurately operate the robots to pick up like the bunch. The peduncle is just about 3 millimeter diameter. So it's quite accurate operations. And so then we're also looking into the applications like if we can deploy these robots for waste recycling facilities, when the waste actually moving on the conveyor belt, actually we can use this again. A visit to the site is for human workers. It's kind of dangerous, although not as dangerous as the nuclear environment, but it's not a nice environment to farm human workers. So what I want to say is robots should be deployed to the environment where they should be, and maybe not ready for our homes, but this environment definitely we need robots to be in the front line and take our human workers in a more nice environment, okay, to reduce the risk of their life. And so that comes to the end of my presentation. Thank you very much.
Thank you very much, Kita. You've given us a brilliant insight there in some of the latest research going on around robotics. I think you're sort of shattering any preconceptions we may have had about what robots actually look like, beyond what we've been used to up to now. So let me introduce our third speaker for tonight. And just before I do, don't forget, we're looking forward to your questions, your perspectives. So please have your questions ready. Type them into the chat if you are participating online. But let me introduce our third speaker now, and that is Dr. Isidro Durazzo Cardenas. Isidro, welcome. Over to you. Thank you.
Thank you very much. Good evening to everyone. The title of my talk today is Autonomous Railways, Infrastructure Inspection and Repair Vehicles. So first, a little bit of an introduction. As I said, my name is Isidro. What I do at Cranfield has been mentioned before. I'm a senior lecturer in life cycle engineering. So sometimes I feel a little bit of an imposter when it comes to robotics, although I've been working on them for the last 7 or 8 years. Mostly I'm a user of them. So if you haven't heard of Cranfield University, I wouldn't be surprised. But if you draw a line from London to Birmingham and then from Oxford to Cambridge, right where those lines intersect, that's what Cranfield University is. And the interesting point about Cranfield University is that it's a university that was created just after the Second World War. And a lot of what we do is related to aerospace, and we have our own runway and so on. But amongst the other things that we do, we rank very high when it comes to funds from industry. So a lot of what we do is really very applied. We only a postgraduate university means that we don't have undergraduates, mostly people doing masters and PhD work at Cranfield. The concept of my talk today, like I said, is rail inspect and repair vehicles. And the concept came and the motivation came from Network Rail directly. So, there was a move towards small machines a few years back. And these came partly from the European Union. The reasons for using robots for the railways are to do with safety. So you think about when Network Rail is able to perform maintenance, which is mainly what they do. I mean, in addition to manage all the stations that we use, they also maintain the track and so on. The times that they got available to do maintenance is usually in the middle of the night. And it'll be somewhere outdoors. And, it doesn't matter what time of the year it is. It might be raining, it might be snowing, and it's a lot of difficulties with people doing jobs at these sort of environment. So this project has to do with this. The idea of this concept is to do with this. Obviously, we can think about using robots are very efficient, and they would save time as well in inspection and repair routines. So as part of the brief for this idea, the fundamental requirements, there's a long list of requirements of this, but I will cite a few that are very, very clear. For example, modularity in the design, so it will be very easily repairable. It has agnostic principles, meaning that it doesn't matter if it's an unmanned ground vehicle or a drone or some other form of platform. So it will be also agnostic when it comes to the type of task it will do. So it's sort of like a free concept in that sort of thing. The idea, obviously, is that it reduces the time that machines are there to do maintenance. So because these vehicles can jump in and out of the track, so the track becomes free. And, as we heard today, there is a number of safety regulations, and this is quite important for the railways. They also have, as part of this, we must comply with the product acceptance, design for regulated principles, etc. So the principle of it is very, very simple, and I simplify it even further. The idea of this is that a robot, a machine, can take a list of jobs that need to be doing somewhere on the track. It will address one. It will travel to site, and then will position his machinery, the part that will do the job, the end effector, effectively, and so he will then execute the task. On completion of task, he will say, "Supervisor, I complete my task. What do you like me to do? We like to go back to central, like carry on with the second task." And that's essentially what the concept is. We don't work with some of the robots, but this has taken us a number of years. So I'll describe this. I like to describe our work we've done for Network Rail over the last several years, like the journey of development. So very early on, they developed the concept, and we were involved back then with technology readiness level 1 and 2. This was done alongside University of Nottingham and the Transport Systems Catapult back then. We became involved in the environment, in the experiment of proof of concept technology readiness level 3. As we speak, we are technology readiness level 7. And to make sure that we attain the levels, we developed a tool based on the railways readiness levels. So every time that we attain a level, we provide evidence of ticking the boxes when it comes to the readiness level marks that we have. Okay, so I will talk about the development over the next few slides. And like I said earlier, we started with a model. We validated the model. This model is not quite a digital twin, and the language wasn't there 7 years ago, but it's a gazebo model. And it allowed us to test some of the principles, whether, for example, it would slow down when it came upon an obstacle, like shows in there, and so on. So we did some verification and validation of these, but then someone said, well, this is all software. You need to do something that actually is a something. So we first invested in a sort of 1 meter train, which is about 5 inches in gauge. It's a little bit of a toy, as you see there, but it's autonomous. So the thing actually travel on its own, and it will carry on until it finds something of red color, which we place there to mimic a defect. So it will find a little spot or a sticker in red color, and then it will then raise a command for its robotic arm to do a little bit of a pretend repair on a bit of track. So you've seen some of the bits in there. But again, then it will return to base. But again, someone said, well, that's just a toy. Let's do something more realistic. So we moved on. So the next step is technology readiness level 5. And for that, a workhorse vehicle that you see on the left was acquired. This comes from a company called ClearPath in Canada. We converted this into an autonomous vehicle. It comes with a joystick and is used for a variety of uses. We use it in railways, the Army uses it in their uses, other people use it in different things. We converted it into an autonomous vehicle. So now takes an order, like explained earlier from the concept, and then goes and perform that task, positions itself, and so on. So that we took up to technology readiness level 5. But one of the difficulties that we have with this is that you notice that it's using a platform to ride on the track, a trolley effectively, because its width is not quite there to fit between the tracks. So that made this vehicle non-compliant with Network Rail's standards for brakes. So we had to stop with that vehicle, and then we constructed the next version of it. So this incorporates a trolley that's actually sold already in the market. And again, it's something that's operable with a joystick, but we convert it into an autonomous vehicle. So the gray box that you see there contains all the brains for it. And these systems come with a LiDAR, which is a scanner, laser scanner, and we use that to detect obstacles. It does come with a series of cameras. Cameras are for the supervisor to see what's going on, but also to identify objects. We use that for that purpose. And in this particular instance, it comes with GPS as well, but in this particular instance, we fitted it with the latest AI machine inspection. So this is an ultrasonics machine in this machine. What it does, it captures data from the ultrasonics and sends it up to the cloud where it's analyzed. Okay. You notice that we tested this already up to technology readiness level 7. And for that, we had to go to a heritage railway. And we tested there, and it's a tourist railway essentially. But we done that because current regulations don't allow us to use a real track. So we have to use then a situation, the closest to what a real railway is. And so the challenge with this, before I've moved, I forgot to say something that's quite important. So I'm not going to jump back, but I will say that when I show my map of development, there's a footnote that says the exploitation route for what I'm showing today is for us to provide a spec for the supply chain. So that will be the exploitation route for this, because we want to encourage the exploitation of these technologies. So Network Rail will say, here it is, anyone that feels able to supply this will eventually do this. We also, to an extent, are giving this away so it can be achieved. Okay. So the next case, and the reason we tested in a heritage railway was to demonstrate that this could be used for ultrasonic inspections. Network Rail already does ultrasonic inspections, but what they do, they use a train that runs at about 30, 40 miles an hour. And then whenever it thinks it found a defect, it could be a crack, for example, it flags it. And that's all it can do. Then a person will pick up the report and say, I'm going to go and find that. But it's a person that does it with this sort of manual equipment. If the tag is a GPS 1, there's 7 meters uncertainty, you would think this person probably need to walk 7 meters, then the resolution is not as good. So it needs to go on the other side of the track for the other 7 meters, right? So there is a sort of a hidden kind of thing. It needs to find it. So part of what we're trying to do with the machine is to remove that step. Okay. So that's how we set up the test to kind of carry on that sort of demonstration. So we've done this already, like I said, in a heritage railway. This is Derbyshire. It's an aerial view of the test. We run this over 250 meters. So there are some defects on the track that we were to inspect. We used the machine that I showed you earlier, and we set it up to go. So you see that we indicated these are cones of different colors. And what it means to us is that where defects are and where the vehicle communicates with the integrated AI inspection kit, because it comes from a different company, so they've got to talk to each other. But the cones allows us, the researchers, to figure out what's going on, because it's really very difficult to see a train or a vehicle that's running at a certain speed and you don't really know what's going on. You only see it moving, but it's actually doing its work, right? So that was part of the reason why we do have cones and so on. So I do have really nice videos of this professionally made, almost like a documentary, which I have links for at the end of my presentation. I'm not going to show them here, but if you share the presentation, then you can look at these videos yourselves. So the results of this inspection were fantastic. All of the defects that were seeded, and noting that this is the same site that Network Rail qualifies their inspection machines, we found all of the defects that they were seeded for it. Okay, there were some limitations in the work that we would do. Like I said earlier, we were using a system that uses AI and uses the cloud for diagnosing. So yes, in the middle of nowhere, we lack sometimes signal, GPS go off, etc. This is the kind of thing you'll find when you're testing things outside where they, outside the laboratory, we say, right? So a little bit of problems with the localization as well. So there are ways to improve this, and we're not going to deal with all of the issues, but we hope in the supply chain can also chip in. Other projects that we've been involved with is climate resilience. And if you look at data that Network Rail publishes, it's about £100 million every year that they have to pay with issues with either flooding or wind and things of that nature. Sometimes a bit of a branch or a tree falls onto the track. It causes a lot of disruption. And if you think about it, if a train is delayed, the following train is delayed, and so on and so forth. It's a big thing. So we've been investigating this with some funds from Innovate UK. We come up with some ideas as to how we can do this and use our machines with our robotic arms to remove those fallen trees, for example, out of it. And we found some of the flooding issues, the most critical ones, and how we can set up a set of robots, a swarm robotic system, which might incorporate some drones and so on to help facilitate restoration of services as soon as possible. So that's the idea of the latest we will be trying to do with Network Rail. So I'm going to show some of the things that we're currently doing. And this is one of our robot cameras looking into some of the objects that we placed in our own tracks at Cranfield. We have about 20 meters of track that we use for testing robotics. What you're seeing there is a trampoline, which happens to be one of the main things that Network Rail has to deal with. So we're looking to try and characterize these. This is actually work from one of our students, trying to identify using artificial intelligence. Yep. So we're moving in that direction. Another thing that we do is we do have a collision avoidance systems. We claim is to do it's friendly, it's collaborative with people. You can see one of our students there. He uses a cardboard as a second obstacle there to simulate another person, because we don't find many people that want to stand in front of a moving robot for these type of demonstrations. So we also have a 3PO and an R2D2. But what you're seeing here is a LiDAR and characterization of its working, the distance that there is between the machine and the moving obstacle. Alongside this, we have okay. So this is another video showing the camera on the robot, and what it's doing. You see a lot of text in there, but what we're trying to do is teach our robot to differentiate between a trespasser and the action it should take. So this is one of our researchers pretending to be a trespasser, so the machine will stop. Then once he moves out, the robot will carry on working. All is done on its own kind of thing. But also, we will have workers, and so one of another students will pop in camera shortly, And what the robot's intended to do is just slightly different. It will tolerate a person that's wearing a high vis as a person that he can collaborate with. Okay, so that's part of the things we do. There are many, many issues that we currently facing: location, how we understand the environment, etc. There is a lot to do with regulation, and this is fresh out of a student report. We're looking in collaboration with VIVAB how we can map out what is missing in the sector and the general cross-sector in terms of compliance and regulation. We're very concerned about how we use machine learning and AI, because this is the bit that we deal with. This shows other aspects of compliance and regulations where it's missing, and in this case, where our robot work is. So what it says specific coverage is to do with our work, and the clearer green is to do with across industry in the UK. Okay, so like I said, further things, further videos about our work are showing this link, so hopefully could be shared. This is a photo of us in our team, and just to acknowledge the work of many students and people that collaborated with us over the years. Thank you very much.
Oh, thank you, Isidro. You've given us a real insight there, I think, into work to develop robotics, really, I think, and overcome some of the challenges of applying them in the real environment and maturing through those various technology readiness levels. I think that's a great case study. So thank you, Isidro. We will move to our final speaker now, and I'm very pleased to introduce Dr. Steve Davis from the University of Birmingham. Steve, over to you.
Thank you very much. Afternoon or evening, everybody. Just as you said, I'm from the University of Birmingham, from the Institute of Robotics. So I'm presenting today on behalf of myself, but also on behalf of Samir, who is the director of the Institute of Robotics at Birmingham. And as you've heard already, she's also the academic lead with the National Committee. So just a little bit about Birmingham and robotics. So the Institute was established to bring together kind of all the robotics work from across the university into a central focus point. So both Samir and I are from engineering, and there is robotics in the obvious places, in engineering, in computer science, but we also have robotics expertise in the law school, which is obviously relevant here. We have robotics expertise in the health department, in the materials department. So what we're doing is bringing all of that expertise together into a central location, which is what the Robotics Institute offers. So what I'm going to do today is talk to you about a recent initiative that we've got, which is a large EPSRC funded project. So this started in October last year. So it's a 35 million EPSRC manufacturing research hub, and what we're looking at is automation and smart machines around the circular economy and around circular manufacturing. So Samir is the director of this. I say £35 million we've got in total. We've got a lot of industrial partners, which I'll show you in a minute, as well as our academic partners. It's, I say, a seven-year project. But I say, looking at developing RAS technology around and smart machines around the circular economy. So we're leading this at Birmingham. So we're the hub here, and then we have spokes around the country. So up to Strathclyde in Scotland, down in the southeast we've got Brighton, all who are bringing particular expertise into the hub. As you can see here, we've also got the sort of the regions involved as well. Each of our academic partners is leading a technical theme, which I'll come back to in a while and tell you about the main areas that we're actually looking at here. And then we have a number of flagships as well, again, which I'm going to mention. What we really want to sort of like emphasize here is that this project is very much cross-sectorial. A lot of these hubs that we've had in the past, and we've been involved in them, are sort of very specific to a particular industry. Our nuclear hub that we heard about before, or the space hub that we've been involved in the past. What we're doing here is looking at this in a really cross-sectorial way, looking at resolving challenges across multiple sectors. And you can see this reflected in the industrial partners that we've got involved, from small SMEs up to some of the large primes, to some of the sort of public sector and private sector organisations as well. And some of these are potential end users, some of them are equipment suppliers. So we've got that large network of industrial partners, including things like venture capitalists who are actually looking to see how we take this from the end of what we're doing in the research hub to the kind of the next level. So, I mean, why are we doing this? So looking at just some of the current challenges around these what known as value retention processes. So how do we recover value from products when they reach the end of their life? And there's just some figures up here. I'm not going to go into particular detail, and you could look at these across a whole range of different products, but just things like wind turbines, for example, the number of wind turbines that are going to come to end of life is increasing rapidly. That's a problem we're going to have to deal with, and it's a problem that we're going to have to deal with in increasing volumes. A similar one, and we hear about it. There's a lot of EV batteries. There are still relatively small numbers of EV electric vehicles around. If the sort of targets that the government is aiming for, there's going to be a real problem with EV batteries that need dealing with at the end of their life. And we're not talking tens of years down the line with. This is a problem that needs addressing now. And so the sort of challenges that we're looking to address here is actually, when it comes to dealing with these processes, the technology and the innovation is actually relatively low. Where this processing of these products is done, it tends to be very manual, very labour intensive, particularly inefficient. So it lacks that ability to scale up, because if it's a manual process, yes, we can throw more people at it, but that's not really a realistic solution of scale up. There is limited, if any, cross-industry collaboration at solving these problems. Individual industries might be looking at it for a particular product, but they're not looking at it in sort of a holistic way and working together to actually come up with solutions that can be rolled out across multiple sectors. And then one of the other big drivers behind this is actually sustainability concerns, particularly around critical materials. We don't mine critical materials in this country. We're reliant on materials from other parts of the world, that we have no control over those markets. And often it's in parts of the world which are potentially unstable. So how can we overcome that? Well, one way is to actually recover the critical materials that we've got in our end-of-life products and reuse them. So instead of mining for materials, we can effectively mine the waste and recover the critical materials from them. So what our sort of grand vision here is for the hub is to basically forge a transformative step in this area around the manufacturing ecosystem, using smart machines, AI, robotics, intelligence, automation to actually advance the technology in this area, and ideally position the UK at kind of the forefront in this idea of globally in terms of the circular manufacturing. And what we're looking at here is kind of the circular economy aspect of it, the robotics aspect of it, and the sustainability aspect of that challenge. Now, I'm not going to go through these in any real detail, but this just gives you some idea of the economics and the environmental benefits of doing this. The circular economy could generate an enormous amount of money for the UK if we actually sort of start looking at it more seriously. It can create enormous numbers of jobs as well. And some of the other things that we actually will be looking at, so I'm going to talk about the technology that we're going to be developing, but also sort of the more business side of things. And one of the statistics there that really jumps out is actually 80% of the product's environmental impact is determined during the design stage. So we're not actually necessarily designing product with end of life in consideration. And can we change that? Remanufacturing contributes to the UK economy, and that could increase enormously. If you're not familiar with the idea of remanufacturing, it's effectively taking a used product and restoring it to as good as new condition, so you can use it again. And that's one of the things that we're looking at as part of this part of the hub, and we have experience of already in Birmingham. And I'll show you a kind of example of that with a case study, as it were. So this is the case study I refer to. So what we've got here is an example of a turbine, for example, or it could be an electric vehicle. So something with an electric motor or an electric generator in it, containing magnets. At the end of the life of that product, what we can do is recycle it. And we're all familiar with recycling. You take your product, you break it down into its sort of original materials, and those materials can be used again. But actually, is that the best thing to do? It's better than throwing it away, but actually the amount of time money and effort and energy that has to go into that is not necessarily the best thing to do. So actually, it's much better if we can take that motor out of the EV vehicle and actually just remanufacture it. So return it to new without actually taking it down to its individual raw materials again, repair it, remanufacture it, use it again. Or if we can't do that, can we get out the useful bits of material out, like the magnets, and reuse those magnets? So you can see we've got various different pathways that the product can go through here, with recycling at the far end, but there are things that are potentially better to do before we get to the stage of actually recycling it down into its raw materials. So we've set ourselves two grand challenges here. So one is to radically transform the sustainability of sustainable use of critical materials, as I've mentioned. Can we get the critical materials out of product so we can use them again? So in the example there, can we get the magnetic material out of an electric motor at the end of its life, or the materials that make up a battery, for example? Can we get those out and use them again? And then the other thing we're looking at doing is radically improving the productivity of what we call the re-ex processes. So these are our recycle, our remanufacture, our repair. It's all of these processes that I've mentioned at the moment. Where they are done, they tend to be done manually, and there's very little in the way of robotics and automation within that area. So yeah, these are our two challenges. One about the materials, one about actually the technology, or the lack of technology to achieve this. And so we've got three work packages that I'm going to go through in a little bit of detail, just to tell you what the hub is actually overall doing. We've got four technical themes here. So we've got one around sensing and inspection and things like digital passports. We've got one around collaborative disassembly, so where we're taking a product apart using automation, but it's collaborative. So there will be some parts of that task that can be done by automation relatively easily, but there will be tasks that are actually incredibly difficult to automate. So you may well still have a person in there doing part of the job. And obviously that raises issues around regulations and safety and all sorts when you've got people working collaboratively with robots. We've got a theme around hybrid remanufacturing, so looking at actually what happens to the materials as it's reused, and can we use it again, and how does material degrade through its life. When we've got a theme around separation of materials. So taking that example of the magnets, how do we separate the magnets from resin potentially that they might be embedded with in an electric motor, or the sort of carbon in a battery? So those are our technical themes, but we've also got three non-technical themes that support this. So I mentioned about products not being designed with end-of-life processing in mind. So we've got a theme that's actually looking into that. We've got testing and validation themes. Everything we've got to do has got to be proven and validated. And then we've got a theme which is running sort of throughout the project, which is actually looking at business models. How do we encourage and help industry to incorporate the changes that we're talking about here into their business model? And we're going to demonstrate the technology that's been developed here in a number of industry-led flagships. And as I mentioned, this is very much cross-sectorial. So we've got an industry flagship around energy, one around medical, one around electric drives, and one around large structures. And then we have a community building activity that goes on top of that. So just very, very quickly, I'm going to talk about some of the flagships. So the flagships at the moment have not been fully defined. I say we're in the first year here of the 7-year project. So we're working with our industry partners to actually set up flagships that demonstrate what the outcomes of this work. But potential examples in the energy area could be things in the nuclear sector. It could be some of the work we're doing around disassembly of electric vehicle batteries. So you can see here a robotic setup we've got for disassembling the batteries from a Nissan Leaf. So this is one area. We have a flagship around medical. So we're one of the flagship suggestions or one of the projects here is actually with Diabetes UK. Can we take diabetes tests and actually, instead of them just going to waste, can we recover material from those? And some of the challenges there are, how do products actually degrade? If you use a plastic container over and over again, actually, how does it, in the sterilisation and cleaning process, how does it degrade? How many times could you potentially use that product before it cannot be used again? So there's all sorts of challenges around healthcare. The electric drives flagship, so I've mentioned this, so this could be something that's like a a small electric motor, which might be sort of very high volumes that need processing, so very sort of needs to be processed quickly. And then at the other extreme, we're looking at the electric generators from a wind turbine, for example, which are much larger, much lower volume, but are incredibly dangerous because of the sort of sizes and the forces involved in the magnet. So the sort of thing where you don't want a person doing that sort of disassembly. And that again could be across multiple sectors. It could be electric motor from from an EV. It could be an electric motor from potentially in the future aircraft, or it could be a really small electric motor from some sort of consumer electronics. And then flagship around large structures. This again, it's been developed, but some of the potential areas is potentially one around aerospace. So where we've got carbon fiber structures, for example, increasingly being used in aerospace, very, very much more difficult to reclaim those materials than a traditional metallic aircraft. So how can we separate the resins and the carbons, for example, carbon strands, for example, to use them again? And so that could be an aircraft wing. Similarly, it could be a part of a wind turbine blade, for example. So this comes back a little bit to touch on what the National Committee is doing and how that ties in with the hub. And as you've heard about this from the first speaker, but we're not just looking at the technology here. We're actually looking at kind of the obstacles that are preventing what has been done in the past actually reaching industry. The hub is looking at the low TRL research, but obviously we're really interested in how this gets to industry. So we want to get this to innovate projects to take it to the next level. We want this to be deployed in industry. But as you've heard before, there are obstacles around regulations and standards and things that make that difficult for us to achieve. So different sectors having different sets of regulations, a solution that we would like to apply across multiple different sectors may meet different standards, different regulations in each of those sectors. So there are problems around that. There are problems around kind of deploying and understanding potentially the risks of the technology that we're developing in particular areas, for example. And each of the stakeholders, the leaders, the people on the shop floor will have different priorities to the technology that's being developed. And so what I think has become clear from the National Committee is there is no the standard answer for every industry, which would be great from kind of my point of view as a technology provider and someone that's producing these solutions, but that just isn't the case. And so some of the work that is being done here around this is actually looking at a framework as how regulations, standards and things can be incorporated into the work we're doing. And this is a part of the work that a colleague has been doing, looking with industry, producing this problem casebook, so identifying common challenges that multiple sectors are actually all facing together that we can sort of collectively try and resolve. And then what the idea is then is to produce a solutions casebook, so actually a set of technologies and such like that actually can be applied to all of those. And this is where the sort of the systems, the sort of the integrators come in at this stage, and then obviously is the deployment stage where things that we as academics don't consider but clearly need to is things like risks and all of the things that are associated that when it gets that much further down the line closer to the deployment. And the framework is also developing some different pathways, some requirement pathways, so looking at the regulation, setting up regulation pathways and standard pathways that kind of guide the work that's being done, and then also providing support. And one of the things that the hub is looking at doing is actually providing a sandboxing case study that can be used here to help this work that's been done by the National Committee actually be exploited in a test scenario. And so just to finish, there's a number of questions that have come out of this work. So how do we bring cross-sector RAS community together to help improve innovation kind of for everybody rather than some of the work that might have been done in the past in silos? And how do we encourage the whole life deployment of RAS from its design stage, but also considers that all the way through to end of life when technology and the products that we're developing have to be disassembled. But also, this is the journey that everyone has to go on together. So we've got to make sure that the stakeholders, the leadership, that the regulators, the person on the shop floor is all sort of brought along with this on this journey together. Now, as part of the hub, we have a number of different committees, and we have an industry steering board. And one of the things I would just like to say is if there are people on here that are interested in joining that steering board, offering anything to do with regulations and standard and what have you, we're very open to people joining that. So what I would say is if you are interested in hearing more about this, more about getting involved in this, then please contact myself or Samir, who is the director of this, and we'll be able to give you more information. And I've had the wave, so that's my time to stop.
Thank you very much, Steve, for introducing us to that fantastic project being led by the Birmingham Institute for Robotics, and also bringing us back, I think, to where our first speaker, Vibhab, started, thinking about some of the challenges around regulations, standards and ethics, the current maturity of development of RAS in the UK, and perhaps giving some insight there into how we can overcome those challenges. So we'll move to our Q&A session now. We have around 30 minutes for this. What we will do is take questions both from the room here at the Institution of Civil Engineers in London and also from those of you joining online this evening. And I'd be really interested to hear your perspectives on what you've heard. And don't be afraid to put your questions and challenges to our speakers today so that we have a really fruitful discussion. So just some basic rules. First of you, for those in the room here, we will have 2 roving microphones. So please raise your hand, wait for a microphone to come to you, and then we'll all be able to hear the question that you're putting. If I can ask you to give your name and affiliation, that would be really helpful. And also please indicate which members of the panel you would like to put your questions to. For those of you online, you've had a chance to post your questions in the chat. My colleague Nick Shaw will be monitoring those questions. So we'll intersperse between those in the room here and those online in putting the questions to the panel. And again, give your name and affiliation and who you would like to put your question to. So let me invite now questions, and I'll start with those in the room first. David, thank you.
No, thank you, Mark, and thank you, panel. My name is David Hurst. I'm affiliated with the Hazards Forum as a trustee and also on council for the Institution of Civil Engineers. I work in the energy sector, and I'm working with some large energy generators at the moment who are going through some difficult and challenging periods and trying to keep their gas-fired power stations working with an absence of welders. So I'd like to ask the panel, so in terms of collectively and not individually, I think on this, about the robotic and autonomous solutions which help solve what has become a national shortage in skilled welders. With the decline of heavy industry in Europe, we've lost those skills. But we now need to have something which replaces that sort of individual qualified and very skilled welder to operate in different fields. And I noted there was some quite interesting rail analogies where we can see some hot work taking in a very defined environment. But quite often, that happens infrequently. There's lots of railway lines, I know, but in order to scale up, in order to get the solutions out there in a commercial environment, they need to be able to do different types of materials and work in different environments, with lots of different problems. So what work is going on transitioning from the laboratory to the work environment, which helps address that very critical and very immediate challenge we're facing at the moment? And where are my welders?
Brilliant. Thank you very much, David. Who would like to start? Isidro, thank you.
Yeah, it's in use, I guess. Yeah, but thank you for the question. It's quite interesting. I'm not directly involved with welding itself. However, I've seen and I know of Network Rail, again, using European funding a couple of years ago to develop a machine that will repair by using welding. So that could be made available to interested people. So I need to find information for you to send directly, stuff like that. But in the context of the railways, obviously, the robots or the way we operate the robots is in a line essentially as we follow the track, and that maybe is a slightly different scenario to what you're proposing. Not in that there is research across Europe in the railways sector dealing with some of these challenges in not just welding, also cutting water jet processes and stuff like that. So there is some movement going on. I'm not directly involved in those. I can't really give you a lot of detail, but I will give you some clues as to where maybe the information could be found in certain areas of the railway sector.
Thank you, Citro.
Okay,
Yes, thank you.
very good question. Just to come back to what I was talking about, the application of robots in vineyards, so the same problem. So with lack of the skilled workers actually can do the picking, or you can't rely on volunteers. And particularly when during the January to March, they do the pruning. And so in the UK, it's quite difficult to find that skilled workers to do the pruning, make sure that the wine is production in the year. So I think that comes to the same problem, the skilled worker labor shortage in the UK in various sections, railway, welding workers, farming, every sector. And I think one reason is because of the aging, right? Population aging, but another is, are we training enough skilled workers to keep the workers to attract enough people to work in that area? I mean, from what we learned in the project, Innovative UK project, is we tried to use the teleoperation system to allow one person to operate multiple machines. So first of all, you have a semi-autonomous machines they can work in. We have one person remotely monitoring multiple machines working together. And if some machines goes wrong, the human can immediately intervention. So that is the way that we are currently working. And then it's not only relying on the worker maybe in the UK, but if we have robust communication system, then you can have workers from other part of the continent or from other part of the world. They can actually work on that just through remote teleoperation. So that is the way that from our project, what we proposed is, if a skilled work in the Spain, because they are not too hot to plant to plant any vines, right? So they are free there, so they can actually do the work for our UK farmers, and then without travel, we solve a lot of problems, like use the technology. Yeah.
Well, I think I'd quickly add to that.
Please,
So,
thank you.
I mean, you'll know that robotics have been used in welding for decades. Your car will have been welded by a robot. But the challenge you've got, I guess, is it's not lots of products that are all the same. It's that variation that a person is able to do. And I'm no expert on welding, and I'm no expert on AI, but it's a challenge which is across multiple sectors. It's not just you that's looking at this issue of variation. That's the way robotics is going. And the things like teach by demonstration, where people will show a robot what to do, and it won't just copy what the person has. It will have the intelligence to actually work out what the task is. So if you say kind of weld round here and that, it will say, "Oh, I'm following the edge," and it will know what to do. So that technology is developing, not just in welding. That's a challenge across multiple sectors where they're looking at variation. The food industry is a good one. No two slices of bread are exactly the same. How do you deal with it? So yeah, robotics is moving more towards that. Not everything is the same.
I think the only thing I'll add is, I think the simple strategic answer is, are we thinking strategically about these shortages? The evidence is limited. Individual sectors are certainly working in this space. So, but more needs to be done. I think I've just noted it as one of the things that the committee should probably talk about, because there's ethical considerations here that will need to be looked at. The other thing I will point to is the World Economic Forum has just published a report in September. I think it's worth a read, which talks about physical AI. So it moves away from basic AI to sort of embodied to physical AI. And it highlights these problems, the fundamental coming together of AI and robotics that will need to be examined. And in particular, talks about context-independent robots. So are we moving to a point where robots are able to recognize use cases which are very similar and adapt and learn? And essentially, that is the future. And how to sort of explore that. And it combines the ability to perceive, it combines the ability for dexterity, because I think how you extend that, but to also think deeply and develop systems around. Yeah, and I was joking about this at the beginning. Certainly in the regulatory world, labels matter. A cake is a biscuit, biscuit is a cake. What are you talking about in a robotics framework? How does that context change? How are you describing a change of context? And really, that deep thinking needs to happen right now. I will certainly urge you to look at that example, and please reach out to us. I think it's a very interesting case that we should explore. And the report talks about the experience of Amazon, for example, and how they have scaled stuff and how they have combined multiple different types of robots and a kind of a universal robotic system to enhance some of the productivity issues that they were having, or in cases where they're trying to improve efficiencies. So I would certainly examine that, but very interesting point. And I think strategically, we're not doing enough.
Thank you very much. Just one final word. Kito, I don't think I'm going to be able to sleep tonight with that robotic snake in my mind.
Fantastic. Great case study. Thank you for your question, David. So other questions in the room here? Not yet. Okay. Nick, have we got some online?
Just while we are checking the online, add a little bit about that question. I forgot to mention that the robot is actually also learning while we're doing the tele operation. We record all the data, so the joints, and we also have now researchers are integrating the fingertip sensors, like our human hand. They collect all these different data, and then with those data, with the AI algorithms, they can actually train it. So by the end, supposed to be fully autonomous. Yeah.
Thank you for that additional detail. So we have a question online. Nick, do you want to put that?
This question crops up during Vibhab's talk. It was around ISO standards. Is there talks with ISO about creating a standard or standards, or do they already exist?
They already exist. So ISO TC 299 is a committee that is doing a lot of work on robotic standards. And there's a whole host of standards, including aspects of language, safety-related elements, and there's a whole host of work also happening at a European level at Senelec around robotics. I think the challenge remains of how to extend that into sector-specific applications. So there's some cross-sector application, and there's a lot of standards being developed. But then there's, as we have highlighted, some very sector-specific challenges that come across. And one of the biggest challenge facing RAS is, to what extent can it be sector agnostic? Is every RAS solution a customized, sophisticated solution to absolutely fit its unique needs, or can it be generalized? And how far can you take that? And I think that exploration will be absolutely essential, I think, if you are to extend it. Because if you look at the example that, as I mentioned at the beginning, 3 perspectives of RAS. It has a technology with AI coming in, becoming complicated. It has a product. So if you look at the example given from Cranfield, as a product, it's getting accepted. But the light bulb example, I always give this example, so apologies if you've heard it before. A safe light bulb initially is just a light bulb. The system definition is the light bulb. Then somebody buys the light bulb. Their system definition is the ladder, the light bulb, and the holder. And once the light bulb is there, the system definition is the whole room with the light from the light bulb. And the big challenge really remains when we think about these deployments as part of the wider operational system. We really need to develop standards and acceptance criteria there so that they can be thought of when the product is being initially designed. Because the challenge always becomes the robot itself works, But if you put it in an environment where trains are moving around very, very fast,
Yeah.
now what happens? Who's assuring the safety of that? So I think standards are being developed generically, but I think operational specific standard, the operating model, capturing the operational context, publishing it, in an open way so that developers can access it and can really define and start to build the robots. I think that's the next step.
Yeah. And Vardhav, can you expand on that a little bit about the role of standards? Because this field, the pace of development is so rapid that I guess there's a challenge there that the standard almost becomes out of date once it's developed. How do we think about that?
I think
the way we develop standards in this area.
I think with great care, because I think a lot of the standards initially being developed, certainly in early stages, even in AI, and are principles based. So the idea is to get some principles, language, common ontologies, at least pinned down, and procedural approaches, so common approaches to designing stuff. It's always a difficult balance because if you recall, I talked about scaling and it becoming a product. And by definition, when you move in that direction, you will start to move towards some degree of prescription and specificity when it comes to technology. And how that challenge is mapped, I don't think we've cracked it. But we are certainly starting to, I can only speak about our organization. I know BSI does a lot of work here in this area. They have PASs, which are kind of early standards. So there's a real need to think proactively about standards and start thinking about the principles and how they will develop. Rather than reactively. And I think that will be I haven't given an answer because I don't have one. But the balance needs to be struck. And I think standards bodies really need to be proactive in developing the standards rather than waiting for the technology to develop.
Yeah.
And we have to have the skills to do that, really.
Yeah. And how are developers being engaged in development of those standards? Because they can give a real useful perspective on this, because it surely is in their interest ultimately, but they may have considerations around protection of their own IP, I guess, which can become a blocker to that. How is that being tackled?
And I think it works both ways, particularly for state centered standards organizations. Certainly us being one of them is, to what extent are you developing standards which are giving a competitive advantage to a particular supplier or not? But I think more needs to be done to engage with the supply chain. And I think it's a useful reminder that people who use standards are not operators, they are manufacturers. And what you're fundamentally trying to do is codifying the knowledge that people have locally into standards so the suppliers can actually develop products without having to necessarily engage and know everything about the local environment. And I think for that, you have to engage with both the operators, but really understand that the users of this system are people who will manufacture things and people who are developing things. And I think that shift in perspective really needs to happen with standards bodies.
Brilliant. Okay, thank you very much, Vardhav. So, can I attempt some further questions? Yes, gentleman over here.
Thank you, Panampalam Linkeshwaran. My question is, I'm just going to look at it a very simplistic point of view where you've got a robot and you want it to have a function, and I'm just going to pick up the railway. I want a train driver, so it's going to be automated. So in that sense, the robot is able to function as a train driver per se. Now, from planning to deploying for that to happen, what sort of time frame do you think it is going to be? And then also to follow on from that point where it says, right, I've got a robot, we want to reuse these components once it's finished its functionality in some format. So what sort of design life are you thinking that this robot is going to be? That goes to Steve, and in your interchangeable, renewable part of the components of the robot itself. So in that sense. And the third point, I think you actually said it earlier, whenever you put a robot, that physical status where it is being placed, it can be toxic, be it nuclear or for welding, etc. Have we actually thought that these components that we are trying to design the robot can withstand that, and it will have a multi-use of that system per se?
Okay, a multi-dimensional question there. Shall we start Isidro, would you like to start with that?
Yeah, well, thank you for the question. If I understood correctly, the first question is to do with autonomous driving of the vehicles, right? And whether they could essentially replace humans. Is that yeah. I mean, I've been to Denmark 3 weeks ago, and I went onto the metro system, which is operated autonomously already. So it's a good indication that this can take place. Don't know whether there are any unions or fights or anything like that. It does work. With regards the life of the robots, it's kind of fun in a way, because the area that I said I'm sort of take to be an expert on is life cycle engineering. So from my point of view, we try to extend the life of high value assets as long as possible. And this in itself is a challenge within engineering. Saying this, what we observe or we want to try to do with the vehicles, I also mentioned this, is we are actually compliant with Network Rail's design for reliability principles. What means is that we're designing the vehicles with expectation of whoever owns them have an understanding of how long will they operate and what will be the maintainability consequences of owning and operating a vehicle like this. There's a lot to be done. But on the other hand, to counterbalance this argument, the railways, particularly the plant machinery teams, they've observed an approximate 7-year life cycle to their vehicles. And this is to do with the drop in reliability with time. So I haven't actually directly answered your questions to contextualize some of the facts surrounding the life of what we do. We do encounter that for the type of machines we work with, we use, like I shown earlier, a vehicle, a platform that's already a product within the rail market. So this is already being standardized and compliant with the expected lifestyle. So these you can buy and use. But on the other hand, I also mentioned that our vehicles come with cameras and lidars and stuff like that. That's not compliant with any of these policies, because there isn't frameworks yet, I think. I need to confirm this is actually true. And puts it in us in a different, in an interesting position, because we've got elements that have a very well-known life cycle and others where we suspect we don't know. Because, a LiDAR, when we purchased ours 3 or 4 years ago, it came from China without, we didn't have much documents to go with. It is latest or, state of the art, if you like. And therefore, there isn't a history of how these things would fail. So I didn't answer the question, I think, but I gave you some facts.
Just on autonomous trains, I mean, there's plenty of standards out there, and there are, I mean, DLR is so,
I was aware of that, but the reason is you've got a robot, you want to replace that. Of course, whatever happens in the media, it happens. But the intention is that you already started with the statement, it needs to be as cost effective as possible. So if you did spend, I'm just going to say £1 million, now someone who invests on £1 million is going to look for a return. So you would need to answer the question in the relation that return on investment is appropriate. If you're going to discard it, I'm just going to say in 3 months, nobody's going to buy that. Yeah, and that goes back to that environmental condition where it is being placed. And we are also faced with another problem. If it is internal in a factory, that's fine. The moment you leave it in a public place, when a product is, and which was the original cost, is it £10,000? Is it £1 million? And it's being controlled. If somebody actually takes it in whatever format, or whether it's stolen, broken, hit, whatever condition it might be, we just got to think about that in that sense.
I think insurance frameworks will become interesting in this space. So I think we have to look beyond robotics and answering some of these questions of redeployability. I think is I talked about it. I mean, scale is important. These are very expensive pieces of kit. You may move away very quickly from sort of causing human harm to a very expensive asset that it can now be targeted, changes the game completely. But I think insurance frameworks will also massively help, and the role of the state really here because I think with a lot of deployment of this kind, but when you started talking about autonomous trains in particular, there are wider ethical considerations, and so there has to be a very clear vision and a very clear signal sent to the market around what the vision is strategically of producing these things and pushing them in. So for example, a lot of countries have robot density targets, for example, that will double it in 10 years. So that combined with sector-specific signaling is essential, because you're right, investors need sustainability, they need certainty, and initially, certainly with these systems, you will have to invest, and there's a degree of risk involved. Groups like ours and the state more widely has to really examine that to see how that can be opened up and how that can be reduced, and what other mechanisms can be put in place to allow for these systems and for it to be attractive to the private sector to really invest in. But I'll say this again, UK is third in terms of private investment in early robotics. So actually we're very, very good, but the deployment rate isn't great. So there is something to be done there to bridge that gap.
I'll just quickly add that you raised a really important point. And one of the themes that I mentioned in our hub was looking at business models, because it's no good us, like you say, creating a solution for somebody that lasts 3 months. How do we deliver technology that actually is useful in a business scenario and allows them to actually operate and fits in with their business model? The business model has got to change, but it's got to be realistic, because the business has still ultimately got to make a profit.
So we have a few minutes left. Any further questions? I think we have some regulators in the room. Can I tempt any of you to give a perspective? Yeah, thank you, James.
Hi, I'm James Walker. I'm from the Office of Rail and Road in the Railway Safe Directorate. I think just a question for Essie Dreyer about the rail inspect vehicle that you talked through. I think you said it's at technology readiness level 7. So what are the timescales for operational deployment, if it was to get that far?
No, I don't think we nailed it down yet as to where.
There's the answer.
So
the robots have spoken, I think.
So what I said is that we demonstrated to technology readiness level 7, and that's in compliance with the readiness levels from the railways. But I think the next steps, 8 and 9 and whatever comes after, will come with the supply chain. Our view is that we're not in the market of developing and selling these products. Now there is network rail, and at this point, I think when we find and define, we're happy that we're complying with regulations and the product can be used. Then it's for network rail to find and finalize the spec to be open to the market. But it's not resting with us. It's something for the supply chain to engage and supply.
Can I just do one more plug? Rail is clearly very well represented at the robotics at this committee. So I think, and also here. So I think I'm very encouraged by that. But the other thing I would say is the TRL levels won't necessarily translate to approval level, and I think that would be an interesting jump as well around how that is done, and perhaps that is where an organisation like ours and yours can kind of help the projects.
Yeah, like I mentioned earlier, one of the reasons we want to heritage railways for doing the tests is that RSSB standards that don't mention robotics or autonomous machines on it, so we're on non-compliance as soon as we put one on the track, kind of thing. So that's one of the first obstacles, and so already people are working to try and solve these issues, but there will be others that continue to grow. For example, I mentioned also artificial intelligence use of in critical situations. Not very clear where we stand on that. And like I mentioned, if we want effectively to have robots are collaborative with people, then at that point, we need to be very, very certain about regulation and compliance.
Brilliant. Thank you very much, Citron. Thank you for your question, James. I will draw our Q&A to a close there. We could go on, but thank you very much for putting your questions. I think we've had a sense tonight of some of the brilliant research that's going on in the UK in this area of robotics and autonomous systems, some of the real opportunities that exist and some of the challenges, and Vaibhav, you mentioned it in particular, that scale up step is the critical one, isn't it? But I hope you've got a sense of some of the work that's going on in the UK around regulation standards and ethics in particular, to help think through some of these challenges and for stakeholders to engage in a really proactive way to exploit the opportunities that exist in the UK, solve some of the safety challenges that we've got, and bring wider societal benefit from use of these technologies. So just some final thanks. Firstly, thanks to my colleagues in the Hazards Forum, Eleanor, Anna and Louise, for helping to organise and run this event. That's much appreciated. And I'm sure you will agree, let's give a special thanks to our panel this evening, Vaibhav Ketal, Isidro and Steve, and let's show our appreciation in the normal way. Thank you very much. And finally, thanks to those of you who have joined us at the ICE in London this evening, and for those of you who have joined online, your participation is much appreciated. So over to my colleague Louise for some final remarks. Thank you, Louise.
Okay, so that's it for this evening. I must also thank Hazards Forum members through their membership. That's how we are able to put these occasions on. There's more to come. Certainly, if you sign up on our website, you'll get updated about future events. Our next event is actually part of the IChemE's Hazards Conference that's in Birmingham at Edgbaston Stadium, where we'll actually be running a workshop on interdisciplinarity, and particularly looking at interdisciplinary learning and how we do it, and how we can do it much better than probably we're doing it at the moment. So that'll be the next event that we'll be running. So if you are at that conference, look out for that workshop. If you're not, we will be doing an event on that next year. So that's something else to look out for. In terms of what happens next this evening, there's an opportunity to consider the conversation, the topic more down at the Two Chairman Public House, where we've got a little bit of food laid on, and we've got a little area at the back of the pub. So do feel, come and join us in an informal environment and ask questions of other visitors here tonight, and also of the speakers. So I think that's it. Or perhaps just one more thing is to say, out on the table outside, there's some literature about the Hazards Forum if you're interested in finding out more about us. And there's also some promotional literature from the IChemE on their upcoming event on digitisation, which again, some of you may be interested in. So that's it from me. And thank you to the people in the room again, and thank you to our audience online joining us tonight. Thank you.